Lobes and Beamwidth. Welcome. In this video, we'll explore lobes and beamwidth, two fundamental concepts in antenna theory that determine how an antenna radiates and focuses its energy. Introduction to antenna radiation patterns. Every antenna has a unique radiation pattern, a graphical representation showing how power is distributed in different directions. It helps us visualize where the signal is strongest and where it begins to fade. What are lobes? In an antenna's radiation pattern, lobes represent areas where energy is radiated. The strongest one, called the main lobe, indicates the preferred direction of signal transmission. The smaller ones, known as minor lobes, represent weaker and often unwanted radiation. Major lobe, main beam. The major lobe, or main beam, is the direction of maximum power radiation. This is the area where the antenna is most effective and focused, providing the highest gain and performance. Minor lobes. Minor lobes are smaller peaks of radiation that occur outside the main lobe. Although they carry less power, they are generally considered undesirable since they waste energy in unintended directions and can introduce interference. Side lobes. Side lobes are a special type of minor lobe that appear right next to the main lobe. They represent wasted power that could interfere with nearby systems or reduce antenna efficiency. In design, engineers often use filters or shaping techniques to minimize these side lobes. Back lobe. The back lobe is the portion of the pattern that radiates in the direction opposite to the main beam, about 180 degrees away. Reducing back lobe strength is important for improving antenna directionality and preventing unwanted signal reflections. Half power beamwidth, HPBW definition. Half power beamwidth, often abbreviated as HPBW, is a key measurement in antenna design. It's defined as the angle between the points on either side of the main lobe where the power drops to half its maximum value, or 3 decibels down. HPBW, significance. A smaller HPBW indicates a narrower, more focused beam, meaning the antenna is more directional. This results in higher gain and longer range, making it ideal for radar and satellite communication systems. On the other hand, a larger HPBW spreads the energy wider, useful for broad coverage areas like Wi-Fi. Summary. To summarize, the major lobe represents the main direction of radiation. Minor lobes and side lobes are unwanted emissions that reduce efficiency. The back lobe points opposite to the main beam. An HPBW defines how focused or spread out the antenna's energy is. Together, these parameters help engineers design efficient and high-performing antennas. Real-world applications. Lobes and beamwidth concepts are widely applied, from radar systems that detect aircraft, to satellite dishes that precisely target signals, and even in mobile phone antennas that optimize connectivity. Understanding these properties allows engineers to balance coverage and efficiency for specific applications. Thank you. Thanks for watching. I hope this helped you understand lobes and beamwidth in a simple and visual way. If you found this useful, don't forget to like, share, and subscribe for more easy to understand tech explainers.